circle, radius, large circle, dilation. So here's the question, dilation. It's going to be large to small, large to small. The large one is 20. The small one is 4. And you put them in the calculator. Or you can simplify both by 4. Gives you 5 over 1. So this is the correct ratio, the correct answer to this question here. So I was initially going when there's no, because I don't see the answer here. But let's look at the questions. Let's look at the answer choices. This one says from the smallest to the largest. So this is large to small. Smallest to large would switch it around to 1 to 5. So that's a correct answer if we switch it around. So I'm kind of torn. Maybe B, but the real correct answer would be A, B, C, D, E, which would be 5 to 1. And we'll figure it out. On this one here, the the way they name it is very important. DE goes to AB, so DE goes to AB. So we're going to go 30 to 24. As DF goes to AC. So the way this is worded, guys, is out here. It's saying DF goes to what? AC. I guess I changed colors. He goes to, and then he goes to AC. But the question is coming off of this over here, which is BC, BC to go to EF. So we don't have anything on these two sides. We don't know what's going on here. So we really can't work it out. So I'm just going to say, let's just put 25. Let's put 25 here. So now we can actually work it out. All right, I'm going to go with which side? 25 over here. Going to BC. Going to BC, which would be X. Then we just go back and look at all of this list. We'll write it out here. So DE, this is DE. Right here, first a second, goes to AB, goes to ABC. So then come into this other side here. We come back to this figure here. We go FE, or EF, you say EF, goes to BC. EF goes to BC. Now we can work it out. On this one here, I'll just do any of you want, and I'll work it out right here. So we're going to come back over here and do any of you want. Let's just start on the document. No. Menu 3, 1, and then we go control Z 30 over 24 is equal to the control fraction of 1, 25 over X. And then we put comma X, enter, 20. So right here, X is equal to 20. So it should be this one if they worded it right. Okay, so on this one here, it says max 5.6. So for $40, she grabbed a relationship between the cost of the search and the number she grabbed, And cost of search and number search, she labeled the vertical axis cost. Let's just start doing that. This is the unit per, so that's pretty easy. So no, right here's 0, 0. Vertical is cost. Make sure you know that. You determine how many shirts you're going to buy. Which of these shirts here comes first. Then you can pay how much you need to pay. You know, why would be here second. So at 5, we'll go 1, 2, 3, 4, 5 shirts. She paid $40. It's going to go up here. And it's saying the slope of the knife. Guys, then how you approach this one. Realistically, I need just 2 points. There's a line going through here. It's proportional. Make sure you know that's proportional to the origin. On that note, if you can just think about this, we have our coordinates given to us, like say like easy 0, 0, and then 540. When it comes to those two right there, distance stretches, manual and 3, you can see each shirt is how much? $8. So let's go through the spreadsheet stuff to my area calculator. I'm going to go ahead and own a document and put 0, 0 for the first point, and then move out 5 shirts for $40. Come right here, menu 413. P control madness. What it said. And there it is. Slope is 8. That's one way of doing it. Another way I think would be super awesome is doing the rise over your run. That M is equal to rise over run. So let's come out here from here to here, rise is 40. From here to here, my run is 5, which again gives me 8. So on this one here, guys, you have the area of a dilated figure. Okay, so this one, once you think about area, well, there was 3 things we had. We had perimeter, area, and then we had volume. And when it came to your perimeter, your scale factor did something to it, but when you did the perimeter and you got the prime, they had actually gotten the scale factor and kept the scale factor and used the same scale factor. When it came to the area, to get the area prime, they got the scale factor and did the scale factor squared with area, okay? Whatever the scale factor was. For the volume, they used some scale factor, but to get the volume, the prime, they squared it. So now this one here, for the volume of a new figure prime, they cubed it. So we come out here, and looking at this one, since we're talking about area, we're going to use this idea. We have to use this idea. So for here in that volume, same with area. So the original one is 48, and the new one is going to be what? 12. Initially, you think that the scale factor here, whatever they use, to get this one, you multiply, right? You want to think that this one, 48 times the scale factor, would give you 12. So you see it's getting smaller. These can't be it. And initially you think that, okay, it's going to be what? The original one of 48. And then you multiply by some scale factor. And it looks like 1/4. This is 1/4. Remember that. And this one here is 1/2. It does look like it's going to be what? 12. It looks like 1/4. It's 1/4 its size, but really we did the scale factor and we squared it. So we go 48 times. Well, we want it to be ultimately to be some kind of scale factor squared to give you the 12, right? So we go with this right here, 48 times. Let's put this right here. This, I'm just go to the answer already and show you what it's supposed to look like. We go with 1/2. Okay, so 48 times the 1/2 squared would be 1/4. and that would give me 12, and that checks out, right? So 1/2 squared is going to be 1/4. So that's the idea right here, and that's where this number comes in here. It's going to be a misleading one. Boom. And let me just show you the wrong answer. This is the wrong answer, and I'll put it at 1/4, and I'll show you this is not the correct answer, because if you have the new area, which is supposed to be 12, we'd get the original one, and we multiply it by 1/4 squared to give you 12. Well, this is really weird. 48, right? 1/4 squared is going to be 1/16. Okay, so, and then, is that equal to 12? 48 times 1/16, which would be 3. And they're not equal to each other, because you want this one to be what? 12. But it's not 12. It's giving you 3. So that's why that one's just completely off. It's kind of a crazy idea, but it checks out. Okay, so listen here. Once you see this thing right here, you want to come out here. Oh, you can answer the answer choice. Yes, definitely. Definitely. This is a joke. Y equals mx plus b. Once you see a table, you do this in spreadsheets. I'm going to use these two right here, just because. Because 0, 1, choose easy, and then -3, -1. We'll do this in spreadsheets, menu 4 and 3. Oh, look at that. I need to have 0 and put a 1 here. -3, -1. -3, -1. 2, -3. 2, -3. There's my answer. Too easy. Okay, so basically we're going to have, so if we can go through these two, it should go through all three. So I'm going to change to these two. Okay, the slope, I think it's 3547, 3547. Let me go back to that one. 3, 5, 4, 7. And it's asking for the slope, so we'll be having the slope here of 2. This one's really easy. Once they give you the data points on stuff, you want to draw a line through it. Please make sure you know that's going to be a positive relationship. It is linear, and it is, I must say, a very strong positive trend, okay? When x is 18, x 18, ooh, let's look at this, 2, wait, 4, 5, 6, 7. Okay, they go by ones. 5, 6, 17, 18. Oh, that's easy. So it's only one past it. Right about here. Luckily I have these tools. I think you have some tools that you can draw too, guys. Kind of extend the line out. Now the answer comes off this line right here. And then come this way roughly. Now we'll go 13. Directly varies. Once you hear varies directly proportional, this basically means that it's proportional. And that goes back to 6th grade, to fractions like this. Okay, the number they give you here is $500. Don't even think, just put 500 first because it came first. 20 hours, it'll be H here. Now the same 50 hours, put H here to be 50. And then X up here. And that's a classic hands-on. Looks like a joke. Okay, let's look at this one real quick. We're going to go 500 over 20. So we go real fast. Come over here. Oops. Count over here. We're going to go to menu 3, 1. Control fraction. I believe it's 500 over 20. That's going to be equal to control fraction here. 500 over 20, x over 50. X over 50. Now, if you look at this one, you see this one? The small number, big number. Small number should be bigger. So just looking at that real quick. and then comma x, so 1250. That seems about right. Think about this. So 1250 going here, right? So this one, like twice, this one will be 40, and that'd be like 1,000 already. And half of it would be 250, definitely. So it's definitely going to match up pretty good. This is a good rectangle and a value of x. It's a rectangle, so what do you know? When it comes to being a rectangle, this side's length is equal to this side's length, and this one is equal to that one. So this one goes back to rectangle ideas probably like third grade, first grade, second grade about the rectangles. Now this is the 8th grade part, which is just set up some random thing equal to some other random thing. But now you have the calculator, which is a joke. So you solve this, 3x minus 18. So go back to calculator, menu, 3, 1. Oh, great, I forgot the numbers. 3x minus 18. 3x minus 18 is equal to 5x minus 40. Minus 40. Remember those, that side is equal to that side in a rectangle. And then we're going to comma exit, and it's 11. Let's read the question actually. What's the value of x? Yes. 11. They could change it up just FYI and say what's the side length. In case that ever comes up, you basically have to get that x and plug it into this right here. Well, what's the side? 5x minus 40. When x is 11, we have 5 times 11 minus 40. Just saying, if it ever asks for the side length, this would be the answer. But this is the answer for this question. It would be 55 minus 40 with 550. So try to yada yada yada. Okay, so plus an hour. So that the equation is 25x plus 40. Okay, okay, here's the equation. Perfect. Proportional. So when it's proportional, we have y is equal to mx plus b, where it's going through the origin. Basically, where b is equal to 0. So you don't have a b here. You don't have any plus anything. You don't have a plus 40. So it's non-proportional and linear. Yes, it's no, these are linear. All these things are linear. All these things are really good are linear. Okay. So I just briefly read this question. Such a good question. So what type of association would you expect between a person's golf score and the time spent on the driving range? So let's look at this. Time is always x, deal with that. And then your score is always, well, the second thing is always your y. So it's going to go score, y, and then x will be your time. So the more time, what happens to the score? Does it go up or down? So the more you practice, the better you get, right? So a high score in golf is bad, just FYI. A low score is good. What does that mean? So it takes you less shots to make the holes, and then it takes you a lot of shots, makes your score go bad. So this is what's going to happen. If you spend no time, you can have a lot of bad shots, a lot of bad scores, high scores. But as time goes on, you get better, your score comes down. I don't even know. I was going to say something like that, and it could be, I doubt you'll improve a lot really fast. And I doubt you'll really stay really bad, and then all of a sudden really improve. And you can only, so going back to this one, it's not going to be consistent for everybody. I'm just saying in general, As time goes on, the more you practice, the lower your score should go. As time increases, check. Time increases, no. No, I think there is association.